Hi guys, so I'm back with another example on proving trig identities, and this time it is number 5. As you can see up here, number 5, we have left hand side and the right hand side. Again, we can see that the left hand side is like there's room for simplification on the left hand side more than there's room for simplification on the right hand side. So we are going to start with the left hand side and try to simplify using the algebraic methods, using our prior knowledge, some common sense techniques, and the the formula sheets, okay? So if you look at the left hand side here, obviously there is a cosine of the difference here, cosine of a minus b, and we know the cosine of the difference formula, which is, so we're going to write that. So it's cosine a, and then cosine a, cosine b, then when there's a minus here, so it changes to plus sine a, and then I have sine b. Right, that is my cosine of the difference formula, and this whole thing has to be divided by cosine a. So I'm not going to do anything with I'm not going to try to simplify or use formula sheet for the denominator because it's pretty simple in the simplest form actually, right? So from here, guys, again, once I do this, I write the formula for the cosine of the difference, then I get something like this. Then I'm going to look at my right hand side. Looking at the right hand side, I can see that I have two terms separated by a plus here, right? That means here, what I should try to do is, since I'm looking at the right hand side, we have two terms separated by a plus. So what I should do here is, I should also try to separate them. So in most of the other examples, or in some cases, we have to try to combine the numerators for when we have two fractions. But sometimes we may have to actually do the reciprocal, like, which means if it's already combined, we may have to like separate it and write it as two different fractions. Guys, that is why each problem is unique and different in its own type, and I think that is one of the reasons why students struggle with these proving identities, because at times you're trying to combine the fractions, and now here you want to break them apart. But guys, that is all part of mathematics. Sometimes you need to combine them, sometimes you need to break them, depending on how the right hand side or the other side looks like, okay? So we have to be able to manipulate functions based on what we are trying to make them look like, okay? So here, let us break them into two pieces, and we are allowed to do it because there's a common denominator, which basically means that this divides the first piece and it also divides the second piece. Let us do that, and then from there we'll see what happens, okay? Cosine A, cosine B, that is the first term, and I'm going to divide that by the cosine A sine B, right? And then there's a plus, then there's this term which is sine A sine B, and divided by the cosine A sine B, cosine A sine B, right? Guys, let us take it up here from this. So now let us try to simplify. We broke it into two pieces. Now let us try to simplify, and there will be a lot of room for simplification, guys. Here, the cosine A and cosine A will cross out, right? The same term. So if this crosses out, I'm left with cosine B. I'm left with cosine B over sine B for the first one. And then let us look at the second one. Again, if you look at the second one, the sine B and sine B will cross out, and I'm left with sine A over cosine A. So I'm going to write sine A divided by the cosine A, right? Guys, wait a minute. Now, what is cosine over sine? Cosine over sine is nothing but it's the cotangent. So this is cotangent B. And what is sine over cosine? Sine over cosine is the tangent. We know tangent is sine over cosine, so now we're going the other way around. So it is the tangent of A. And because these are added, I can rewrite them as tangent A plus cotangent B, and that is exactly how my right hand side looks. So that implies the left hand side equals to the right hand side. Here we have, guys, we proved that the left hand side is equal to the right hand side. Again, we worked with the left hand side. We wrote the formula for this. We broke it into two pieces because the right hand side had two separate pieces with an addition in between, and then from there we were able to get it exactly like the right hand side. Guys, that is number 5. There's more coming up in my next videos, so keep practicing these types, and I will share new types with you as well. Okay, guys, be confident with this. Don't let these proving identities intimidate you. It is still algebra, and then of course you need to use the formula sheet to kind of replace formulas and then get it look like the other side.